Okay, our objective is to talk about proportions, similar congruent figures, as well as on there, so just a heads up for that. We will do a review tomorrow, and then that way Monday when you come in, we'll just get started right away. So I'll either post the review answers tomorrow or give you a copy of them at the end of class so you can make sure you're prepared for Monday's test. That's the last test for this semester, so also remember that. Okay, we're closing grades here soon. A couple more homework assignments I'll continue to add in. Your note packets from Chapter 5 I did add in. I will give those back to you tomorrow so you guys have those for reference. All right, so starting with this warm-up, which I know some of you guys were a little stumped on. The first thing that I wanted you to do was draw the 3 triangles. So let's draw them here. Small, medium, large. I'm not going to label them all. I'm just going to draw them here real quick. So the small triangle, who can tell us how to label these? Mary. Okay, where does the 13 go and where does the 12 go? Okay, good. Okay, medium triangle. Good job, Mary. Sean, what can we label? Good, 24. Good. Large triangle, what can we label? Matt? Awesome. Okay, find DE. For number 1, what is a proportion you can use to find DE? Briar, what's the proportion you use to find DE? Did you do this? Good. X over 24 equals 5 over 12 is one option. You could have had this a little bit differently. Either way, check and see if you got 10 for DE. So then DE is 10. Where can we label that up here? If DE is 10, Annalise, where does that go? Good job. So I'm going to cross this off. I'm going to put a 10 here. Kind of makes it a little bit easier, especially when you guys go to geometry in 2 years. Fill back in what you found, okay? Just take your time when you're finding it. Okay, let's go to FG. What's a proportion you can use to find FG? Justin, what'd you use for your proportion for FG? You didn't get that far? Okay. FG, Alyssa. Oh, perfect. Sorry, I had to think about that. X over 30 equals 10 over 24. Awesome. What's another one? Matt, what's another one you could have had? Awesome. Anyone have any other ones for number 2? Any other proportions? Okay, regardless of your proportion, what did you guys get for the answer? Donatus, what's FG? Good. 12.5 centimeters. So you also could have had 5 over 12 equals x over 30, which is the same thing as 10 over 24 equals x over 30. So there were a handful of proportions for this one as well. Okay. You guys with me now? Do you think this is easier now or no? Okay, now the last one was apparently harder according to you guys. Let's first label, well, some of you said that. Let's first label where FG goes. So where are we putting FG? Make it a little easier. Justin, where are we putting that? Will you say that again? Good. So we're going to put 12.5 on the big triangle where X is. All right, now that we have all that, what's a proportion we can write for AE, Doug? Did you have your hand up to tell us it, or? Okay. No, I want to know the proportion. Okay, I'll have you tell us the answer in a second. Sean, what proportion did you use? Awesome. X over 10 equals 13 over 5. So, Doug, what did you get for the answer? Good. 26 centimeters. And again, X over 10 equals 13 over 5 is one proportion for this. And that's using the 10 that we found in DE. So yes, you may use prior segments that you already found. Okay, Annalise? Hold on, you did 13 over 12. Yep, that works. Yep. Okay, where do we label 26? Where does that go? Briar, where does it go? Good. Now, do you guys remember what the side's called? If this is a right triangle, what is this called, this side? Anyone know? Annalise? Nope, the side, not the angle. Okay, it's called the hypotenuse. You guys ever heard of that? Okay, we'll talk about that in chapter 9, but just wanted to remind you that side is called the hypotenuse. Okay. Okay, questions on that warm-up? Justin, you okay? Even though you didn't do them? Okay. All right, let's go to the tree problem. Okay, tree problem. So, tree is flat on the ground, casts a shadow that's 51 meters long. A person is 1.6 meters tall and casts a shadow that is 4.8 meters long. How tall is the tree? Alyssa? Good. 17 meters. So if you didn't get that, here's the tree, here's the person, here's the tree's height, here's the tree shadow, here's the person's height, here's the person's shadow, and then here's one proportion you could have used. Here's another proportion you could have used. Sean? Well, in your head, you used a proportion, whether you realize it or not. That's fine. The result of 1.6 times 51. You're doing the same thing as a proportion. You're just doing it in your head. That's fine. Okay, any questions on the warm-up? Huh. So if there's a bonus like the first one, could you guys handle it? Okay. Maybe we'll do another hard one tomorrow. I won't do that. I know sometimes I do, but I won't do that. All right. Let's go over practice 6.5, and then I'll talk about what I had on your desk when you came in today. Okay, practice 6.5. There were only 9 questions, so. Adam. Well, some people were here when I passed them out, but you get here early, Adam. All right, number 1, Justin. Good, 3.4 feet. Number 2, Emma H. Good, 23.4 meters. Number 3, Justin. Good, 8 millimeters. Number 4, Doug. Good, 14.25 centimeters. Matt, number 5. Good, 9.6 feet. Charles, number 6. Good, 6 meters. Number 7. Let's see. Mary. Good, 25 inches. Number 8, Emma M. No. What did you do wrong? You probably just set up your proportion wrong. Adam? Good, 28.8 centimeters. Number 9, Zach? Good, 1.35 feet. Wow, awesome. Very good. Annalise? Number 1, 11.8. Well, the answer should be 3.4, though. Okay, your proportion should be, Annalise, oh, actually, tell me first. What did you have for your proportion? Okay, you have it backwards, that's why. It should be, I don't know, okay, it should be 17 over 30.5 equals x over 6.1. Did you redraw the JKL one? Okay, A, B, and C correspond with JKL in that order. So here's what I mean. So if we have A, B, C, you have J, K, L. AB is 17, AC is 30.5, and then LJ is 6.1, and JK is X. So your proportion, I don't know if you drew them wrong. Okay, but ABC corresponds with, you looking? JKL. They have to go in the same order. Yeah. So your drawing was wrong, which is why your proportion was wrong. So I'm guessing on 5 you did the same thing. Okay. No, I started with A. You look up here. A, B, C corresponds with J, K, L. You can start wherever you want. They just have to correspond. JK is X. JK is right here. Are you looking at that triangle? JK is X. You can't move the X to another side. Yeah, you did. That's what I was telling you. Okay, I'll come back to 5 in a second. Sean? Number 9? Okay, hold on. No, that's okay. Yeah, that's okay because they didn't specify. I'm sorry, I should have said that. They didn't specify inches or feet, so that's fine. The only reason I changed it to feet is when you're talking about height of a person or not. Typically, we talk about it in feet, but no, that's fine. Yeah, good point there, Mary. That's what Sean just said. Are you listening? I guess not. Listen. Okay. Listen. Yeah, I'm tired today too. We're all tired. Justin. Okay. Okay. Annalise had a question on that too, so we'll go over this one. Okay, number 5. So this one was kind of like number 6 that I started with you yesterday. So I am going to first draw the smaller triangle like this, and then the bigger triangle like this. So Justin, let's look at the small triangle first, which, let me make sure I draw these right. P, Q, R, S, T, R. Okay, so we have S, T, R for the smaller one, and the bigger one is P, Q, R. Okay, so Justin, the smaller one, what can we label? Oh, that would be maybe why I do, but I'm still going to keep doing it. Annalise, do you need me to keep doing number 5? Okay, so the small one should be 30, 36. Annalise, what did you have labeled for your bigger triangle? Okay. No. What's QR? This is why I did number 6 with you guys yesterday. No. Not 30. Good. So X plus 36 is QR. That's why I did 6 with you. Just getting 6 started with you guys yesterday. Be careful if you have one side is X, the other side is 36, and it's all the same length. You have to add them together. They're not like terms, so technically you cannot add them. So based on this, one proportion you could have is X plus 36 over 36 equals 38 over 30. So that's one proportion you could have. Annalise? Yep. Yep, same thing. Anyone else have questions on either setting up 5 or solving? Alyssa? Yeah, the answer for 5 should be 9.6 feet. So what I recommend you guys doing is you do cross products, make sure you are distributing correctly, combining like terms correctly, etc. If you guys don't get 9.6, let me know and I'll go through every step. Sean? Yeah. Well, when I say anyway, Sean, I mean that they have to be proportional. So like this has to go with this has to go with this, or this has to go with this has to go with this. They have to be proportional. So whether you're going from here to here, or from here to here, here to here. That's why in my head I always come up with all those different ones. You just have to be consistent. If you start on this side, you then have to go to this side. Then you got to go back to here, over to here. Does that help? Okay, Emma M. Number 8. Okay. Can I move this? Is everyone okay now? All right. Number 8, let me just look at this real quick. So we had side length of A and then the corresponding side length of B. So Emma M, we know that A corresponds to B for 5 to 8. So A and B correspond by the ratio of 5 to 8. You then know side A has a ratio of 18, or has a side length, sorry, of 18 centimeters. So you have to find what length goes with B. Okay? That's why. You have to do 18 times 8 divided by 5. So what I suggest is keep all the A's on the top, all the B's on the bottom. Okay? You look tired today too. You okay? Annalise? Okay, I already erased it, so let me draw it again. Okay, Annalise, A, B, C corresponds with J, K, L. So we drew them so that they go in this direction. Doesn't matter how you start it, you just have to be consistent. A goes with J, B goes with K, C goes with L. They just have to be in the same spot. That's for every single problem like this. Okay. Okay, anyone else? Anything on the homework? Comments? Questions? Alyssa, did you get that 9.6 for 5? Okay. All right, thumbs up, thumbs middle, thumbs down. We're not done with that lesson per se. We'll do a little more of it today. Okay, Charles, you're okay, right? Okay. All right, let's take a look at those papers I had on your desk, okay? So I told you at some point we would talk about conversion factors. So kind of like I gave you, Sean brought up a good point, kind of like I gave you the divisibility paper as a reference, I'm also giving this to you as a reference. No, you do not have to memorize this. I don't believe that learning something, for you to learn something, you have to memorize it. No, I want you to learn it and remember it. So don't memorize these. This is something for you. Now, this chart is what I just want to talk about for a couple minutes. Anyone know what this arrow means up here? So I just want to start with, if I have this arrow going from here to here, anyone know what that means? Mary, what does that mean? What's that telling you? Yes, yeah, so give me an example. So to get from meter to what? What do you do? Yeah, to go from meter to decameter. See this little thing here? You divide by 10. All right, well, what does this mean? What is this telling you? That second arrow. Sean? Awesome. And Charles, what does this third one mean? Good. Okay, so that's what those arrows mean. Why is there gram and liter underneath meter? Doug? Good. Decaliter. So these are all the same. These are just your base units. Okay, it could be any of those. So to go from here to any of these sides, that's what you do. Alyssa? Oh, good. The same way? Oh, nice. Did you have to memorize it or just learn it? Okay. Good. Nice. I'm glad to hear that. Did you guys all learn this last year? Some, I don't understand. Yeah, I know a lot of you know it, but I want you to, if you visually remember this, it is helpful. Like if you can see this chart, because it does help. Okay, so let's go over here to this side, okay? This arrow tells you to get to from meter to decimeter, multiply by 10. This arrow, to go from meter to centimeter, you multiply by 100. Third arrow, to go from meter, gram, or liter to millimeter, you take your meter times 1,000. Okay, so those are your top conversions. Some of your calculators do convert for you, but I want you to be familiar with this chart. Okay, throughout the year, I'll throw in some conversions, and we'll talk about them throughout the year. You will see some on PSSAs, but not anything really complicated. So I'm not going to make this very difficult. I just want you to understand the basics of this chart. Sean? Exactly. Yes. It's nice. And we're going to do some examples, just not right now. Okay. So let me just go over the bottom part. What does this arrow mean? What does that arrow mean in red? That one, this part's a little weird. Zach, what does that mean? Careful, not divide. To go from, good. So go from kilo, we'll say meter, kilometer, and to get back to meter, you have to multiply the kilometer by 1,000 to get back to the base. Okay, what does this mean? What's that second red arrow mean, Mary? Good. So hectometer, back to meter, multiply by 100. Third one, decameter, to get back to meter, you multiply this number by 10. Same thing goes with all of these, but you have to divide by 10, 100, or 1,000, depending on what you're trying to convert. Annalise, you had your hand up. Did you have a question? Or okay. Yes. Yes. Okay, so I just want you guys to understand how to read this for now. We're going to do some problems with it probably tomorrow as a warm-up, or I'll throw them in somewhere. Okay, so look at the rest of that sheet, okay? The rest of that sheet, the top of that one just tells you some units of length. Some of them are really easy, like feet and yards. I'm assuming you know all those. The miles, from miles to feet, you might know, but it's helpful to have that. Pounds and tons is right underneath it. And then the units of capacity, these are important to know. The cups, pints, quarts, gallons. Okay, so they're listed up there in case you never learned a shortcut of them. When I was in grade school, they taught us a shortcut, like drawing a big G, and then we put like Q's in it, P's in it, C's in it. I don't know if you guys have ever visually seen a representation of that, but that's how I always remember it. Oh, neat. But it's here. Did they? Oh, a gallon man. Does anyone remember what it looks like? Kind of. Who really remembers? Charles, can you draw it for us? I want to see or the gallon man, either one. All right, show me that one. I just want to see if it's the same as what I know. Hold on. Emma, you can show us the gallon man next. Draw it nice. There you go. Say nice and big. Emma's going to draw the gallon man because now I'm curious. Oh. Oh. Nice. This is the way, if Charles keeps doing that the same way, that's the way I learned it in grade school. That was like our shortcut. But the gallon man, that sounds very interesting. Well, I wouldn't say, maybe not a shortcut, maybe just visually. I don't know. To me, it's easier to see something like that than to memorize. Donatus? Wow. Wow. Was this at North Hills? You didn't live? Okay. When did you move here? Okay. What do you like better? Okay. Awesome. I like it. Perfect, Charles. Emma, you want to show us the gallon man? Awesome. So raise your hand if you used this one, if you've seen this one, because I know I have. Emma, that's not the one you, well, prior to now. You know the gallon, so everyone else knows the gallon man. I don't either. Okay, let me see the gallon man, nice and big. Doesn't have to be perfect, go ahead. Well, so am I, it's okay. It doesn't have to be perfect, I'm just curious of what the gallon man looks like. Wait till I teach you guys of the function man. Chapter 8, I'm going to introduce you to who the function man is. He's cooler, I think. Are those the ears or the arms? Okay, shoulders. No, I'm not questioning your artistic skills. Why is it wrong? Hey, she's good. She's good. Okay, guys, let her go. Doesn't have to be perfect. I'm asking her. Oh. Well, yeah. I just am curious how they spread them out. I just don't know where you put them all. Oh. Well, that works. Well, you don't need to do the ounces. So now, do you do that to the bottom too? Okay. Well, yeah, I know, but that's a lot of stuff. So nothing goes inside the gallon man? Well, obviously, but okay. I don't know which one I like better. Huh. Did you? I'm gonna have to look this up online. Now I'm curious. This is different. Add. Emma, thank you. I appreciate that. Guy, hey, it's perfect. It's perfect. All right. Then one more thing. I like that. At the bottom, it's just some other metric unit conversions for you. So just for reference. Now this sheet, I don't like this one as much, but there are some other conversions on this really small type sheet that I printed. I found this I think last year or 2 years ago. So anything that you're not sure of should be on here, or if your calculator doesn't do it, it is here, just FYI. But again, the biggest thing that I want you to be familiar with is the chart that we went over with the arrows. That's the most common that you'll see. If you don't already know a conversion, it will be something that uses this box with all the arrows. Okay, and again, we'll discuss this more. I just at least wanted to give you the papers for reference so that you have it. Charles? Yeah. Yeah. Are you looking at the second paper? Yeah. Fluid ounces. Okay, so you said yours says what, 29 or 28? Okay. I'm not sure why. I'm assuming it's just the rounding issue. So, oh, you know what that means? That squiggle line means approximately. So they probably rounded somehow on this paper, and I'm guessing your calculator's more exact if you see the squiggle line, because they rounded it. So that squiggle line means approximately. Mary? Just another form to measure speed. You will see that in physics. It is for boats. No. Mary, you'll see that in physics. So, yeah, it's interesting to look at that. All right, let's put those to the side for now. I want you to open up your notes. It's page 16. Okay, we need to finish what we started yesterday, which shouldn't take us too long. Okay, I want to start with example 2. With example 2, okay, through some of the examples, which there's only 3 or 4, of talking about the scale models, scale drawing, scale factors again. And then this is the last part of new material before we start reviewing. Your homework tonight has a couple conversions on, but they're simple ones. So when I do explain your homework, I'll have you refer back to that sheet if you need to. Yeah, it's pretty basic. I just like to give you the sheet so that you're prepared just in case. Okay, Doug. 16. Okay, so example 2 says, an enlarged scale drawing of a snowflake has a scale of 50 to 1. If if the drawing is 17 centimeters in diameter, what is the diameter of the actual snowflake? In these problems, there's two things that we're talking about. One is the scale drawing, and the other one is the actual object. Okay, so the actual size. I want you to write down the two things that they're comparing for the ratio. Let's start with the 50 to 1. Which number is the scale drawing, and which one of those is the actual? And they're talking about a snowflake here. Sean? Good. Why is the scale drawing 50? Good. It's enlarged. So you guys know a snowflake is so small. So when you're drawing or making one, I hope it's going to be bigger than that, or else it's going to be really hard to see your drawing. Okay, snowflakes are so small. Okay, equal to, where do we put the 17 and where do we put the x? Doug? Good, why? Yeah, that's the drawing. They want us to find the actual. So after you set up your proportion, use cross products to solve. So I'll let you guys do that. Go ahead and use your cross products. Solve. You will get a decimal. We want to find the diameter of the actual snowflake, which of course is going to be pretty small. Might have, you doing it in your head? Or do you need your calculator? What? Okay. Well, you should be multiplying this, multiplying these, and then divide. Okay, equals 17. Okay. Annalise, what'd you get? Nearest hundredth is fine. No. Annalise, cross products. 50 times x is 50x. 17 times 1 is 17. Divide both sides by 50. Okay. So to the nearest hundredth. Alyssa, what'd you get? Good. So 0.34 centimeters is the diameter of the actual snowflake. When you guys are doing your cross product, I would say to show your work so that you don't mess up with your division. Okay, don't do it in your head until you completely are confident that you can do this. Charles? Yeah. If you convert it, that's actually kind of cool. That's fine with me. You'll make me think when I grade it, so if you do that on a test, sure. Yeah, I guess that it is, for a snowflake, that is kind of big. Your book sometimes is not always, like, factual. They might have just made this up. I don't know. All right, Doug, question? What number are you looking at? Number 3? Okay, well, we're getting there. Just hold your thought. Okay, let's go to example 3. Anyone feel like reading example 3 for us? Okay, Briar, nice and loud. Begonias. It's flowers, Doug. Awesome. Thank you. So you kind of wonder why they're doing this for a floral carpet, but they are. It must be a big deal to design a perfect floral carpet for the palace in Brussels, Belgium. I know. So this must, I'm just saying, like, to me it's kind of weird to know they're making, you're right, to making this carpet like perfect. But you're right. This is very special. Yeah, I guess so. With begonias, Matt. Okay. I'm just kidding. They're special flowers. They're not. Wow. Okay, so I don't. The scale drawing of the carpet is 20, and we know that the carpet wants to be 40 meters wide. So how do we find what that scale factor is? How do we set this up, Charles? No. You don't need to. Don't need to. You just need to find what centimeters to meters is. You don't need to convert. We're finding the scale. You don't need to convert. Hello? Hey. Hi. I do. Yeah, go ahead. That's not right. That's not. No, no. That's correct. And I think mine's like 50 every time I get it. I can show it to you later. I can check it and let you know later. Okay, then that's what it is. Yeah, yes. Yeah, no, no, no. That's wrong. You're welcome. Bye. Sorry, guys. So, Charles, you were, yeah, you're doing, you can do it that way, but they want to know what the scale is. Kind of like the snowflake, you know, what's the actual, what are they going to scale it to? So you're allowed to have different units if it's a scale, okay? So just 20 over 40, and then just simplify them. That's the scale. All they want to know is what is the drawing scale, okay? So actually, let me put the units here. So 20 centimeters for 40 meters. Simplify it, we have 1 centimeter for every 2 meters. So you don't have to convert. They just want to know what the scale is, okay? I will make sure, yeah, it's very basic. I will make sure on a test or quiz that I'm specific about telling you what you do need to find, whether it's converting or just finding that scale. Annalise? On this one, yes. Yeah. Sometimes you use proportions. The next one you'll see is a little different. Okay, all we did was take what the scale was and what they want the actual carpet to be. We're just finding the scale as a ratio. So scale over actual, and then we just reduced it. It's too easy, that's the problem. Okay, let's go to 4, and then that should be able to clear that up for most of you guys. Okay, so 4 says, suppose you decide to build a model of an antique airplane that has a wingspan of 40 feet. You decide to use a scale of 1 foot for every 12 feet. What will the wingspan of the model be? So I want you guys to write down, we have model and we have actual, okay? There's going to be a model of an airplane, but there's also an actual airplane. Let's start with the 1 feet and 12 feet first. What goes where? The 1 feet and 12 feet. MH? Good. So the 1 foot, 1 feet I should say, goes with the model. Okay. The actual airplane I hope is going to be bigger. Okay. On your scale drawing, 1 foot for every 12 feet. So 1 foot represents 12 feet is what that means. Kind of like in that previous problem with the carpet. Okay, the scale versus the actual. Besides the snowflake, typically the scales are going to be smaller, okay, unless you're enlarging something. Equals. What goes on the other side? Annalise, what goes on the other side? No. Mary? Yeah, why does it go that way? Anyone know? Alyssa? Yeah. Good. 40 feet is the actual size. That's how much that antique airplane is going to be. You're going to build a model of it. Okay, you don't want your model to have a wingspan of 40 feet. Okay, too big. Okay, you want your model to be much smaller. You want to scale it down. So let's use cross products and solve. We'll go through this together this time. So multiply across both ways. We have 12x equals 40. So what should the model be for the wingspan? Matt, what'd you get? Good, 3.3 repeating feet. So much better, right? That's much better to make it that has 3.3 repeating feet as opposed to 40. Donatus? Yeah, that's fine. I'm okay with either way. We can start with converting things now. Annalise? Yeah, no, it's the actual. Because you're going to build a model of that antique airplane. That's what they're saying. Okay, I want you guys to try the closing, okay, and then we'll talk about it. So go ahead and try the closing if you haven't already. Read it and then set up what you need to. What? Done. Honest, I like when you're awake. Just hang out for a second. Okay, I want you to read it again. Read it again. You should have map and actual, not those things. Good, good. You guys are doing great. Good. No. Read it again. You're close. Okay, so we have map and we have actual. Okay, how do we set this up? Alyssa, what do we do? Okay. Good job. So there's two ways to do this. You know all the centimeters are going to have to go on the top. All the kilometers have to go on the bottom. You also know the map's distance is on the top. The actual is on the bottom. Okay, you can't have an actual map that's in kilometers. That'll be huge. You want to scale it down. Justin, go for it. Good. X equals 95 kilometers. Awesome. Questions? Emma, you okay? You okay, Emma? Annalise? No, kilometers. You're finding the actual. You're not finding the map. You're finding the actual. Okay, open up your homework packet to 6.6. What'd you say? No, it's not. It's not bad. Okay, I want you guys to do, let's do it all. So 1 to 28. Okay, this, like Charles just yelled out, it's not going to be bad. This shouldn't take you too long. Now, one thing I need to remind you of, the conversion papers that I gave you, you might need to refer to the chart with the arrows. If you do, don't forget you have that conversion sheet. Please open up your homework packet. Show your work on here. You should have enough room. And that's about it. I don't think you guys should have any major issues. Tomorrow we'll go over this. I do have some warm-ups that we'll do that were similar to today's warm-up, as well as some of the things we did today. So, and then we'll start to review. Test Monday. Annalise. Yes. Yep. So, for example, you would do 1 inch, okay, for every 14 feet, and then you need to convert that to be in inches. Is that what I converted it to be? You can convert it either way. I'll check it either way. But yeah, convert it to inches, Annalise. You're just converting them. Alyssa. After the whole chapter 6. So we have to do probability first. Probably not for another month. We're getting there. Okay, everything else, if you guys have questions, email me. But yeah, that 19 through 24 is the converting part. You should be fine. All right, get packed up. Good job today.